So thank you very much for being here. We are talking today about traditional monitoring versus observability. So let's start with the main subject. But first, has anyone, is anyone already using some kind of monitoring for their system, for your system? Okay, so some people is using debug and App Insights from Azure, I believe. Okay, so thank you very much. So if you are already using some kind of monitoring, you probably have logs that you are sending to some backend, so you can look for them in case of any problem. Also, you may have metrics and you are visualizing them in dashboards, and you have set up some alerts based on KPIs you know about that measurement that you are doing. So let's say you have a graph monitoring credit card transactions per second, and you well know that your system should be treating 100 transactions per second. So you also know that the measurement is not constant. So you may have some periods where the transactions go down to 20 transactions per second. And also you know about that kind of operation that 20 transactions per second doesn't last very long. So let's say it's normal that the 20 transactions last 5 minutes, but over that period of time, you know there is a problem. So you set the alert with those conditions, and whenever there is a problem, you got the graph turning into scarlet red, and yeah, you get paged. You have some kind of alert in an email or an SMS or something. So hopefully you never get that, because you are new in the company. It's your first ever on call, and it's 10 p.m. So you are in the couch, relaxing and maybe watching a series, but you are on call, so you have your telephone at your side, and it's 10:05 p.m. and you get paged. So you got your PC, you start reading the documentation about that graph that is in red, hoping the documentation is up to date, which is not. So you start looking into your log system for logs that may tell you what is happening. You don't know anything. You start looking for phone numbers of people you can call for help. And then the graph turns green again. Lucky of you, you can go to the couch again and relax. So that's his traditional monitoring, I will say. It tells you what is happening right now. But you may tell what happened last night to your colleagues the next morning. But what happened? So you don't know. You didn't have the information. You tell your colleagues also next day, and they don't know either. But the issue is happening every day in a non-systematic way. So what do you do? Because you don't know at which time it is happening. So you may have some logs. You identify the service. You may have log and found a log with an exception, and then you have a line of code. So you can maybe debug the application and fix the bug, but oftentimes you don't have any log. So what do? You may have identified the service that is producing the error. So you probably will go to that service and try to add more logs and hope for the best the next time the issue happens. So maybe you will have another log. Okay. So you hope for the best. Maybe you have another log the next time the service crashed. So that is traditional monitoring. As I was saying, traditional monitoring is focused on predefined metrics. So you know what you are monitoring. You know that you are monitoring credit card transactions per second, and you know the KPIs that goes well on that type of transaction. And whenever the transaction goes down, you may set an alert to get alerted. So it's very useful for well understood mode of failures, and chances are that most of your graphs and alerts are because you have before an incident. So you got an incident, and next you do the meeting about that incident, and you decide to make a graph, set an alert, do some documentation about how to treat that alert, and yeah, so that helps you to understand when the failure is happening. So yeah, like the guy that get paged at 10:05, the alert was happening at that moment, but they didn't know why and where that was happening. So traditional monitoring only gets you so far. And what people developing the observability concept have noticed was that. So they realized that was something missing. There was something missing, something to glue all the data together and fill the visibility gaps, so the blind spots. So observability is about understanding the internal state of the system, system-wide, so all services running in the system, and not only services, but parts of the infrastructure. It's about distributed tracings. So we will see what distributed tracing is and why that is useful. And it's about also correlating all that data together. So you already have logs and metrics that hopefully they are somehow correlated because of the timestamps of the metrics and the logs. But now you want to add traces to all that also. So you have like a thread of things that had happened. So why it is helpful? Why observability is helpful? So for me, it is helpful because it enables debugging. It enables debugging, like I like to think about it like the old way debugging, when you put some console log saying I'm here, I passed by here, I got that result, and whoever has done that kind of debugging knows that it's very helpful because it narrows the perimeter of the thing you have to look for. And so you go and add more little messages in that narrowed perimeter, and you may have the bug because yeah, narrowing things is better. But that kind of debugging is only reasonable if you are debugging like one service or one application. But when you have multiple services, because the use case in today's architectures, we have microservices, and you have multiple services for one use case, so you don't have that. And observability tries, and I think it does very well, adding this kind of debugging to the whole system. You may also have another use cases that you have never think about it. Let's say some proof. Let's say you are an intermediary between a e-commerce and a bank, and you are treating credit card transactions. So a user in the e-commerce makes a buys something, and so the the e-commerce sends us the transaction for the credit card, and we ask the bank for the money, and the bank says to us, yes, the money is okay, so we got the money. So we say to the e-commerce, okay, we got the money, you can ship the product to your customer. And 2 weeks later, the e-commerce comes to us saying that they haven't received the money. And we have like all the trace for that transaction, and we say, well, yeah, but the bank answered to us that it was all okay. So we are going to approach the bank and see what happened. And the bank says, no, but I didn't receive the transaction. So we prove to them that they answered to us and they answered that or that thing. And yeah, so that may open eyes at the bank side, and they will be able to debug what happened at that time. So I don't think this is legal proof. This is only proof for something, because we are working with trusted actors, and the bank is not saying to you that they don't receive the transaction because they are bad, but because they don't know that they received the transaction. They don't have the information. So you may give to them the information they need to debug in their side the case. And yeah, how I do observability in an easy manner. So I'm here to tell you that you can't go wrong by doing observability with OpenTelemetry. And I will tell you why. So first, a little of history. So OpenTelemetry, in 2016, OpenTracing was released. And then OpenCensus in 2017 was also released, and they realized that they had the same objectives in terms of observability. They already have realized what was missing on this scope of looking at things and debugging things system wide. So they had a lot of things in common, and also their specifications were very similar. So they decided to merge, and in 2018, they formed OpenTelemetry. And next, in 2019, OpenTelemetry was alpha, in 2020 was beta, and last year, OpenTelemetry was already in general availability. And OpenTracing is officially deprecated. So if you go to their site, they will tell you it's deprecated, and they will tell you to go to the OpenTelemetry site and see the documentation on each that. And OpenCensus is also saying in their site that they merged, and you should be using OpenTelemetry. So what is OpenTelemetry? Well, first of all, OpenTelemetry is the most active project on the cloud native computing foundation after Kubernetes. So they have crazy activity. They are contributions all around the world. And yeah, so first, the OpenTelemetry is a cross-language specification. So they defined how any language that wants to implement the specification should like collect traces, collect metrics, collect logs, and what the kind of information you should put in there. And one part that is very important in that convention is the semantic. In that specification is the semantic conventions. So because let's say you are using some messaging broker, and is not the same that I don't know, another team in your company is using. But if you tag the information the same, for example, messaging destination, messaging server, the messaging client ID, something like that, you will be able to read those traces without inquiring much about that, because yeah, you share the same language, you share the same conventions. OpenTelemetry also provides a collector. They call OpenTelemetry collector, and that facilitates the deployment and the collection of data, and also the scaling, because when we ship that to production, you will be receiving a lot of data. So you need to scale that part of your infrastructure. Each language has also its implementation of the API and the SDK, and also they have a lot of auto instrumentation libraries. So, for example, let's say you are using JavaScript. So you go to OpenTelemetry site. Oh, I missed. You go to the register and you look for JavaScript. So you have a lot of things that are already auto-instrumented. For example, if you are using Express, well, you have the Express auto-instrumented library. That means that when you use Express, you only have to add this library and data about Express and all the HTTP requests that are going through that Express server will be like monitored. You will get traces about that, and you can do with whatever language you want. For example, .NET. Well, about .NET, you have only 4 entries here, but the Microsoft team have already auto-instrumented a lot of things. The ASP.NET Core is instrumented, the HTTP client is instrumented, the SQL client is instrumented, so you have a lot of things that are going out of the box only by adding some libraries and some configuration. And about also the infrastructure, let's say you also have a Nginx that is like load balancing your requests. You also have some auto-instrumentation for that, and a collector. So this is to show you that the activity on this project is very, very high, and you may find any library for auto-instrument your infrastructure and some basics of your application right away. Also, so OpenTelemetry, one of the objectives is to be vendor neutral. So it means that it provides a common specification for all languages to follow. And if you use that specification, the APIs and the SDKs implementations of that specification, you only need to instrument your code one time, because adding instrumenting your code it does not add value. It's the information that is collected by that instrumentation that add values. You need to collect that and send somewhere. And before OpenTelemetry, you had some library that was provided by some vendor, let's say Azure, New Relic, or whatever, Datadog, for example. And yeah, you use that library, you are locked vendor, and you can change the vendor, but you have to re-instrument your library to your application. And maybe also your infrastructure, all things. So that is one thing. So OpenTelemetry is also about ubiquity, because as I said before, yeah, it's not only about applications, but also as about infrastructure parts of your system, like Nginx. And because because there is so much activity, you may have libraries that help you with that. And because of the collector, you also may test test some vendors at the same time, and maybe choose one the vendor that fits you. And you can also have some custom pipelining about the observability. For example, you need to send the information to the data telemetry to, for example, New Relic, or one on-premise Zipkin for just analyzing that data. But you also want to store that data for many years, and it's too expensive to store that on the vendor or even in the premise Zipkin. And so you send that to some cloud storage also. Or you can also have some data analysis, I don't know, big data analysis on that data, and you can stream that over Kafka. So the collector also enables a lot of use cases about that OpenTelemetry data collection. And yeah, so all the major vendors are adopting it, or maybe adapting to it, because yeah, it's like the standard is everyone is using it, everyone wants to use it, and the major languages also had already implemented the basics. So if the vendors don't implement that, they will left out of the business. So yeah, all the major vendors already are able to receive information, data telemetry, on the what is called the OpenTelemetry line protocol. So you can choose whatever you want if you choose to work with OpenTelemetry. So we will see some code and some demo. But I don't know if there are some questions until now.
No questions for now.
Okay, don't forget, if you have some questions, you can ask in the chat and we will answer to them. So I'm starting a Grafana Zipkin server, also Tempo, that is the Grafana Labs solution for data tracing. And I starting also 3 applications. One is called Planning Update. I have also one called Connector, and I have also one called Distributor. And there are also one application that is generating load to those applications. So we will see how that is presented on Grafana. So I also have a Loki in Grafana. There is the solution, the GitLab labs, the Grafana labs, sorry, Grafana labs for the login. And I may have some logs. So yeah, I have some logs. So you may have some logs. Here I have only information logs, but you may have some logs with errors. And those logs can be correlated with the trace. So for example, here I have a trace ID for that log, and I can open tempo for that log. I will close here to better visibility. And I have all the information about what happened and when. So I was seeing a log on the connector, but I also have the logs of the traces of what happened before and what happened after the connector. So this is a use case. The use case is like some planning update is happening, and we need to send to some distributors. So we use the connectors to send that data to the distributor. And the planning update is communicating with the connector via a messaging broker. So it's NATS, the messaging broker. And the connector is receiving that and making a HTTP request to the distributor. So yeah, we have a lot of information about what is happening at each moment on the use case. And so we can add as many tags as we want. Some of the tags follows the convention that is specified in the OpenTelemetry specifications. But you can also add whatever you want there. And you can also add some events, for example. So sending message sent, or processing message processed. So they are events that happen in the span that we are talking about here. And yeah, you have some information also about what is about the HTTP request. So there, in this example, I have the distributor, but normally the distributor is like outside our perimeter. So if the distributor have a problem, I will have here like the error, the 503 error or 500 or whatever. And I will be able to tell to the distributor that they are having some problems. But also in between the connector and the distributor, you may have some Nginx, or you may have some, I don't know, if you are working with PCI, you know that you have sometimes to have some infrastructure outside of your perimeter to fetch credit cards or something. So you may have that here, and you may be able to collect data over that, and maybe enrich your trace here and know what happened, because the distributor maybe he didn't receive the request, but the request was failing on the Nginx that is forwarding the request. So you may have that information, and you have all these correlated and in one, like in only one place. So that is very, very helpful. And you have also information that is, yeah.
Yes, Santiago, we have a question from Benjamin asking if it's possible to add some anonymization filter in the collector. Or
Yes, of
somewhere
course.
else.
Yeah, of course. So you can have in the collector receives the data, process the data in any way you want, and then export the data to whichever backend you want. So yeah, you can put some logic on the collector So you can filter some things about the person that is doing the transaction. So yeah, you can be GDPR compliant. Of course.
Thank you.
So you also have some information here in the timeline. It's like, yeah, every system will be different. So when you start to observe your data, you will learn also about your system and how it is behaving. So here, for example, we can see that the planning update is very, very fast. And then like the connector is not that fast. And also the message, the message was like almost 1 minute in the message broker. So it may be because, yeah, the connector is working so slow and the planning update is working so fast that here are sending a lot of messages. And we have only one instance of this connector, or maybe we have 2 or 3. So yeah, we can maybe investigate if we can scale the connector up and consume the messages quicker. So I'm also sending metrics to Zipking. Like it's the same. You have maybe better visualization in Grafana or maybe not. That is following what you like. Zipking, I didn't find that in Grafana. You didn't find the events like represented here, but you have that in Grafana. So you know that the event happened at this time and the other event happened at this time. So you have some information also here that you can interpret. That yeah, if you know when this event is happening and you know when this event is happening in the code, so you may be able to work this down and yeah, maybe investigate what is happening here and why they are taking so much time. Yeah, so that is for the traces, and we will see some code, how we implement that in .NET. So yeah, this is the Docker Compose planning update, the connector, and the distributor. So this example is in F#, but actually is exactly the same in C#, because you have a builder and you do this for adding OpenTelemetry. But before that, you have to add some packages. So you have to add OpenTelemetry, and if you want to export to the console, you can export to the console. So you have to add the exporter to the console, to Prometheus, to Zipking. So this is like you want to export your data in the Prometheus fashion, where this is for metrics, but for traces in the Zipking protocol. And you can also add the Jagger or whatever you want, but you can also add the OpenTelemetry protocol. And this is normally what all the vendors are already accepting. But also the OTel collector can accept, for example, Zipking protocol or Jagger protocol. So if you may have some applications that are already instrumented with Zipking, you can let it instrumented like that and send that Zipking data to the collector, and the collector will treat that, and maybe if we forward that to the vendor like Zipin, it can also forward that to the vendor as OpenTelemetry line protocol. So you have a migration path that is very, very easy to implement. You can add also some instrumentation, automatic instrumentation libraries like ASP.NET Core for ASP.NET Core and HTTP client. You can also maybe add the SQL client and you will get the instrumentation right away. So yeah, all the here receiving the request is the ASP.NET Core instrumentation, and sending the request is the HTTP instrumentation. So this is automatic. I didn't have to do anything for do that. Only add the libraries and configure that in this way. So when you have add all the packages, you have this extension method over the services, and yeah, you add OpenTelemetry tracing and you configure the tracing. So you set the resource. The resource is like this application and several informations about this application, where it's running, like in what OS is running, or if it's running in a container and in Kubernetes, for example. You have all that thanks to the resource builder. You say also that you want to add traces about a library that you are using. Here is Nats client. And you can also add the auto-instrumented libraries like ASP.NET Core instrumentation, HTTP client instrumentation, and you can add the console exporter if you want, or the OTLP exporter, so the OpenTelemetry line protocol exporter, and you can configure that to send maybe it's to the collector. I have configured that to send it to Tempo directly, because yeah, you can also send directly to the backend you want, and not use the OTel collector. So the reference architecture is something like this. You have an application that is instrumented or is sending telemetry data, and the application can't send directly to the backend. But that is something that doesn't scale well. But for debugging, for putting in place the things is like a good way. But for production, it's preferred to maybe host an agent in the host, so in the same server, or maybe in the same Kubernetes if you are running containers, and the collector will be charged of sending that to the different backends, for example, a Zipkin, or you have maybe a Prometheus or something like that. But you can also have like a collector that is a cluster of collectors, so a gateway of several collectors that are working together to scale the load of the data, the telemetry data collection. And yeah, you do this, and you have OpenTelemetry. Maybe yeah, it's very easy. It's too easy to be true, but it's like this. And you may encounter some libraries that are not instrumented, like auto-instrumented, like the ASP.NET Core instrumentation or the HTTP client. And I will show you that. So I have like a wrapper over the Nats client. To instrument a library, you only need to take a dependency on the OpenTelemetry API. So that guarantees you that the implementation is minimal. So the overhead in the instrumentation is minimal, is like almost a no operation. And that guarantees also you if, for example, you don't add this source, you won't be collecting any data of the over NATS client. So yeah, the users of the library can opt in collecting data telemetry or not. And you may you may implement like this like this. So you may use activity source. That is something that the .NET team added because it already existed some activity API, .NET activity API. So they didn't re-implement all, they only filled the gaps between the .NET API activity and OpenTelemetry, and they filled that gap with activity source. And yeah, so the activity source, you have to name, well, it's a convention. You have to name the activity source like the library. Normally it's the assembly name, but yeah, here I wanted to, I don't want to name that shared, so I want that's client, so I named that. You may also add the version of the assembly, and you will have an activity source that is global to your application or to the library. You can do something similar to instrument your application, but here is for the library. And for the library, you have to propagate the context. So you have also some propagators. So the context is propagated, and when you propagate the context, it's available for the other libraries. So if you don't propagate the context, you won't have information of the correlation information about for example, in the HTTP client. So you have to propagate the context or things will break. And when you have that, you extract the parent context when you are receiving, for example, some message, you extract the parent context. You also extract the baggage from the current the parent context and you set that as the current baggage. You start a new activity with that context. You add some information about it, and yeah, you are done. It's like this. It's not very complicated for instrument a library. And well, this is a messaging library, so you have a part that receives and you have a part that also produce or send. So for the producer, you also have to extract the activity somehow and propagate that activity. So you propagate that with those helpers, inject the context, and yeah, you start also the activity and you add some data and you are done. You have some instrumentation for your library that wasn't already instrumented. So yeah, I don't know if you have some questions. So yeah, you don't have any question. Remember that, yeah, we are the Edge. We are also recruiting, and you can contact us in the Meetup TH Tech, or also in Welcome to the Jungle, or also in our corporate website. And thank you very much for being here. It was a pleasure.